All right, welcome everybody to our April meetup with Angular DC, and here I have with me Michael Hladky. Thank you for joining us, Michael. Where are you joining us from in the world?
From Vienna in Austria.
Awesome. So yeah, with this, we're kind of experimenting on in a new time slot. It's kind of going to be the beginning of the lunch hour on the East Coast of the United States. That's where I'm at. It'll be breakfast in San Francisco, and it'll be dinner in Europe. So everybody grab your food, and good stuff coming for you.
Really nice.
All right, so feel free to ask questions in the chat. I will facilitate relaying those questions over to Michael during his talk. And with that, I will go ahead and go through our meetup introduction slides. And then if you have any community announcements, please post those in the chat with the links if you're hiring for jobs and things like that. So welcome to Angular DC, folks. Just a reminder that all of our events, whether it be virtual or in person, are subject to our code of conduct, which you can check out on our GitHub page, github.com/AngularDC. All right, and thank you to our sponsor, Excella. And let me move these videos around real quick. There you go. We're hiring, including fully remote positions. So please check out career opportunities at excella.com/careers. All right, next, some community announcements. Our next event is TBD. If you'd like to speak at one of our events, for now we're still trying to bootstrap with our group of organizers. So for now, please feel free to DM me on Twitter at Deluca, and we do have a Google Forms as well. But for the time being, it'll be easier if you just hit me up on Twitter. And then next up, following this meetup, I'll be actually speaking at the Angular community meetup. So this is going to be an amazing afternoon of Angular. So please stick around, and you might want to extend that lunch break if you're on the East Coast here. So Michael, are you guys hiring, or is anyone looking for a job? Any announcements you have?
I have multiple. So we have a upcoming meetup in Vienna, NG Vienna. This is a pretty cool chance to meet physically. Maybe not so interesting for your time zone, but for us, very exciting because it was a long time since we met physically. So this is a really cool thing. And the Angular Austria Association will also get more active, and this is more of an international thing where we also try to do stuff that is good for the community. And yeah, if you are based in Europe, we also look for Angular developers in my company. Could be fully remote, could be also in Vienna. And yeah, if you're interested, shoot me an email.
All right, thank you for that. And then I guess in the chat we have from PS Dejan. Hello, Michael. Will we be discussing smaller ng on changes with this, please? So I guess you will be discussing ng on changes.
We will discuss smaller, less work in change detection. Let's say it like this way. The scope, what you need to detect, is smaller. Yep.
Yeah. If you do less work, you can definitely do more and the same.
Do more other stuff, right? Exactly. Or more of the same thing, or more important things.
Absolutely. Okay. Well, today we have a giveaway. We have a giveaway for one license of Wallaby.js and one license of Koka.js. And thank you to Wallaby for sponsoring this meetup. They create awesome software that run your JavaScript and TypeScript code immediately as you type and within your IDE. I personally love Koka and use it. It's great for as a REPL environment within your IDE. It's great for just in an isolated manner, testing out some code, typing it, refine it before you paste it into your larger code base. So it's definitely a cool tool. So please go ahead and I guess the way we'll do this is if you post in the chat, I want a license or something like that, and then after the event, I will pick who the winner is, and then I'll I guess ask that person to DM me on Twitter, and then I'll share I'll be picking 2 people, so I'll share the license information over there. So we'll do it that way. We don't have a great mechanism. If anyone has suggestions on running online raffles, I'll take that. All right, we're coming to the top of the hour here. So today we have with us Michael Hladky to be speaking about Angular performance at scale, and he's Michael is a Google developers expert, a Microsoft MVP, a trainer, consultant with a focus on Angular and RxJS. And I believe, Michael, you're adopting Rx as your middle name. Is that correct?
That's true. That's true.
Yeah, and I've worked with Michael. He definitely knows what he's doing, and he's an absolute expert in squeezing every ounce of performance that's within Angular. So this is going to be a great talk, and I'm really looking forward to it.
Thanks a lot.
And with that, I will recede into the background, and I will let Michael kick off here.
Okay, thanks for this very nice introduction. Performance at scale, high-speed web applications on any device is the title, and I will give a quick context how this demo application come to life. So there is the Chrome team. The Chrome team started a project that is called Aurora that focused on making the open source frameworks that we all use faster and compare them in one and the same type of app, which is called the Movies app. And the Angular team, or Minko, especially in the Angular team, was in discussion for that implementation. And we had a quick conversation, and we decided that we will basically implement that with all the knowledge that we know so far on an Angular application. So I had an honor to implement that stuff. I took over the old state, the unoptimized state, which was not really exciting. If you only look at the performance scale here, it was less than 50. And on the other hand, we have only hundreds and a 99 in performance with the application that we see here. To do that, we will work a lot with flame charts. We will chunk up work on the left, on the right side here, as you see the small box, but we will also chunk up these huge tasks. That is, for example, the Bootstrap phase, which is one of the hardest things that you can try to solve. And to do that, we quickly need to understand the basics of flame charts, and we have different colors here, and all the top level that you see here is either yellow, purple, or green. Also, the colors are reflected here, yellow, purple, or green. And they tell us how much scripting or layouting or paint work the browser is doing. And all these red bars are basically bad user experiences, long blocking tasks that you can see here. They have a blocking area, and they have this small triangle that flags the task itself. We see that in the overview. We have also the green stuff, which is the frame rate that gives us some good hint on the user experience, and we have the total blocking time at the bottom right that also gives us a nice insight and measure. With that in mind, we zoom in one more time to one task, and here we have yellow work, scripting work, purple and green paint work. And I have a dedicated talk on CSS only techniques to deal with purple and green, let's call it like that. In this talk, I will focus a lot on the scripting time, especially the scripting time that we can optimize in Angular. We do that by scheduling. Scheduling is a main concept that we need to understand. And if we look at this very left box here, we can click a button and then we should perform some work. This is this package here in the middle. And instead of performing that work right away, we say, we don't do that. We schedule that work in the future and then perform it later on. And if we would do that, we would give earlier time to interactive. This is this dashed line here because we have another task. And we can also decrease total blocking time and improve the user experience. This is like everything in one picture pretty quickly. We will see it in action, but I've not that much time on the theory in this talk. Still, I will care a lot on introducing all that tricks to you. My name is Michael, as the one already nicely introduced me. I also run a company called Push-Based.io. We focus on Angular development, Angular at scale, and Angular performance, of course. And we do that on many different levels. And I guess when I consult companies, the thing that I try to make sure is the basics. So let's start here too with the basics, with change detection strategies. And Angular has a tree of components with the application reference at the top, and then Angular would render it. And these three images here show you basically three different states a default Angular application can have. Green, rendered. Yellow, over-rendered, means I rendered that component without any need for that, unnecessary. And red means this is a path in my component tree that will receive a change. So this is a broken image. Please excuse me. Imagine boxes here on the left. Let's click a button in this application and try to introduce a change to this small box. So then we see the red triangles go up and mark this path as dirty, and then zone kicks in and calls application ref tick. And then Angular executes and re-renders the application again from top to bottom, and at the very end, this rendering process will end and will also redraw this small component number here and update the purple or the pink dashed area with our new value. This is not so good because if we look at the green and yellow areas, the yellow areas is stuff that we redraw unnecessary, and the green is stuff that we have to draw, really have to update. It is a lot of unnecessary work. So what we can do is we can turn on change detection on push. A triangle, a small delta sign, marks the strategy. And if it is light gray, it means this component was not evaluated. If it is dark black, it means that one of the input bindings of these components or all the input bindings got evaluated and there was no change detected. And if there is a change in its input bindings, or it is on this path, on this dirty path, it will have a red triangle. And if we run the same change again, it looks like this. Click the button, dirty marking, redraw it again with application ref tick, and then we see that the components get evaluated bit by bit. And here number 5, no change detected. So I will also skip all the children. You can see that here, they are not even touched. And then I finally update my stuff. And here we made already good improvements and we did not redraw everything. But still, a lot of the stuff is yellow. And this is like the fundamentals that we all know and we all use. I will stick with that more technical stuff and I will skip a chapter. I will now focus out of my slide deck and I will quickly try to skip a couple of network improvements because this talk should be fully focused on structural directives and what we can do. There is only one small trick that I want to show you with lazy loading resources. And if I open up my application, we have this movie list here, and what people do normally with their Angular applications, I will navigate to that movie list, they change the lazy loading of images pretty much everywhere. And this is not good, because then you would basically delay the time that your largest contentful paint takes. So what I suggest is that you set up an index local variable for this ng4 here, and instead of applying loading lazy to all of them, you just apply it to items that are not the first or second item in the list. And then you basically maintain eagerly loading images for the largest contentful paints in that list, which will always be one of the first images. And the rest of the images are loaded lazily. This is already a pretty cool improvement. The second pretty cool improvement with lazy loading is that if we have this, look at this iframe here, we see this iframe is also lazy loaded already, pretty cool, but it is not really necessary, because this iframe would get interacted with only later on. Let me show you that. If I navigate to a details page, I click on the trailer, and only then I want to show the movie. Lazy loading would down prioritize bootstrapping of this iframe, but it still would do it right away. So what I want to do is, when I hover or I click over it, I want to bootstrap this, and this is easily solvable with another ngIf or RxIf, as I see here, which I will explain later on. Two cool improvements that not everyone knows. But now let's jump back to the presentation, which is here. And I directly go to other improvements for our largest contentful paint data. And if we have a look at the loading of that page, especially the main list, and also the loading of this presentation, we see the list data is fetched very late in time, because the HTTP request is triggered in the component, and the sidebar, also dynamic data, is only fetched when the sidebar is rendered somewhere here. It could be done way earlier in time. This means it delays the fetching of all those resources, and therefore the paint of all my largest contentful images here. So what I did is, with a small trick, I set up an app initializer. My app initializer can return a promise. Then I would freeze and wait until this is done, and then go on with bootstrapping with the application. Or it can return a static value, and then it immediately goes on. So what I did is, I created a method that I call that is void. It returns nothing, so a static value. But inside, I call these HTTP requests already at the beginning, in hope that the data will arrive earlier. And let's see what this one-line improvement gives us. A very nice improvement. Here we have in gray the old fetched moments in time, and in purple the new ones. Sorry. And we see that we have a really nice improvement with fetching the data, and also with rendering the data, because they can immediately get displayed. There is enough time difference when we are here. A really nice one-liner that is a huge improvement for every application. The next thing is the bootstrap phase, and here we start to dig into the scheduling concept. We have a huge bulk of work in the middle, and on the left side, if we analyze all that stuff, we have the bootstrap of Webpack, and on the right side, we have three different areas related to Angular: Angular bootstrapping, Angular app initializers, and routing, initial routing. And our goal should be to apply three different things here to optimize the performance. We either could reduce work, don't do the work, and we did that already with lazy loading of images, because if an image is outside of the viewport, I just don't load it at all. And the second two things that I can do is, I can chunk up work in smaller pieces to have less in one big chunk. And I could also, as a third thing, try to prioritize that work and do the most important part first. With that in mind, let's have a look and let's try to schedule the bootstrap time of Angular and chunk up those huge things at least into two separate things. On the left side, we see Webpack. On the right side, we see Angular, and there is the Angular bootstrap module method that you know lives in the main.ts file. And what I did with a one-liner, I just wrapped it with a set timeout, means I just don't do it right away as a promise. It would freeze into the same task. I do it in the next task, and this gives me, if we remember the theory from long tasks before, a new task. And every new task has a 50 milliseconds time frame of where it is not considered as a long task. So I earned 50 milliseconds less total blocking time. And let's go back. This line here means user interaction is also way earlier, and this not only 50 milliseconds, but as long as this whole block is way longer, I guess 3 times earlier. Then another cool thing that I can do is I could have a look at the next block here, Angular bootstrap time, and then the initial navigation, and I can try to do the following. With one line, I can disable the navigation, and this is often used by people to check the authentication state and so on. And then when they checked it, they go on with the navigation. What I want to do is I want to immediately go on. I do that by just calling .navigate in my app component directly right away, but wrapped in a set timeout so that it is in another task. By doing that, I again earn 50 milliseconds less total blocking time and way more, even way more, earlier user interaction, as you can see from the red lines here. What else can we do? As we see, there is another huge task that we could try to tackle. We could look at app initializers again, and this time from a different perspective. I told you that app initializers will return a promise. A promise normally is a micro task, will get executed in the same browser tick, and then we'll go on. Or I do it synchronous value, then I will just go on, and I could leverage this for the side effect trick before. What I will do now is I will hook into this init method. I will create another app initializer, and with this one line here, I will return a promise. I will return a promise that resolves after a set timeout 0. And with this, again, a set timeout, and with this one-liner here, we can split that chunk up in another piece and again earn 50 milliseconds of less total blocking time. And this is amazing. And if you look now, if you recap the whole bootstrap phase, all the stuff that you see on the right was one big frozen block. And on the left, we have Webpack. We can do a lot of stuff more. We could try to go fully zoneless, which is at the moment a big refactoring, and nobody wants to do that. But it could help to also reduce that. And of course, shipping less code also helps to reduce this stuff. But let's go on. And let's talk a little bit about state and template, which is, after chunking up the bootstrap phase, the biggest, far distance, biggest performance bottleneck, and also clutter of code that you could have. Because a lot of stuff is not synchronous, but a lot of stuff that we display is consumed over APIs, over requests, over WebSockets, and they are asynchronous. They bounce in over time. And there we can do a lot of considerations. Let's start with Angular best practices using the async pipe everywhere and ChangeDetection OnPush everywhere. This is a small component tree, and it displays the initial rendering. This is why all the components are red and everything is green. All the triangles are red and every component is redrawn because this is the first time. But then after an update, I will have this dirty marking, and as I hold an async pipe here for age, I will basically dirty mark the whole path. It's better than before, but it is not optimal. And this is the step where I say, let's introduce small architectural changes. Instead of passing values, if you look here, over the async pipe to an input binding of a child, we could do the following. We could pass that directly, as you see here. What we see on the left, the initial rendering, there is no change because, well, if nothing is here, you have to draw it at least one time, right? But then the updates show us a little bit less time consumption, but still the same amount of components that are re-rendered. Why? Even if we pass the observable directly and we have no change detection at all because the observable stays the same and the values that I shoot through will not trigger anything, I have the async pipe at the very bottom that consumes that observable and calls dirty marking again. Terrible. So what we did a couple of years ago, we introduced the push pipe. Something like the async pipe, a drop-in replacement for the async pipe. I also shipped that pipe for NGRX just without performance improvements. And we basically perform change detection on the component locally. And this already reduces the change detection surface a lot. If we look at this component age, we see still heavily over-rendering there because they contain lists and everything. So the next thing that I suggest is switching from pipes to directives. And there I have to give some technical concept. A component, green box, maintains few container references, the thing that is inside a structural directive like an ngIf. And the ngIf maintains an embedded view, the if and the else template. So on the left, our tree, we zoom in into this one component. There is data entering, there is a double curly brace, template binding, and then two structural directives. So template expression and two structural directives. And if I zoom in even more into those structural directives, we see that they maintain a view container ref and they maintain several embedded views. And when we digged into that source code, we discovered the following line at the top right here. Detect changes on not the change detector ref of the component, but the embedded view itself. And when we saw that, it clicked for us because we are, with the previous architectural change, are able to shoot values directly to a specific place in the template without triggering any push, change detection, whatever, nothing. Completely silent. And here we can consume it and detect only the change of this one single embedded view and not the full component with all the other directives and everything. And this is huge. If we do that and we use RxLet as structural directives that we use, that we shipped, that is also a replacement for the ngIf, we can go down to the very minimum effort, and it also reduces the surface of using 100 async pipe over and over again. If we compare that, we see how dramatic this input is. And here we can even debounce multiple values that came in over time frequently. All the different architectures until the last one, I evaluated and ranked by performance. This is the overview table. Of course, the last one with RxLet is the most efficient one for performance and also for lines of code. So we will try to apply those changes to our application. And what I will do is I will especially try to improve the performance of this very page here with the main list. Let me refresh it quickly. And also the detail page here. The detail page, let me refresh it, is a hard candidate. There are a lot of blocking things. Even if we split it up the bootstrap time of Angular, rendering of the whole component still is not chunked up. So after this stuff is loaded, I can show you. After that stuff is profiled, I can show you that we have a lot of work done with XHR requests and rendering of the full list. And we will try to get rid of those blocking tasks at the end. This is what we can demo easily. And then we will try to work our way towards the beginning. Okie dokie, let's do that. Let's also look at the initial list here. If we refresh that and I do another performance measurement, we should see a similar thing, just less work at the very end. And we also will try to tackle this. I can now click on stop because we don't need to wait. Unfortunately, when video streaming is online, the loading of the profile takes always some seconds. This is a little bit sad, but I like it to wait. No, I don't like it to wait. But it's my job to fill that waiting time with some verbal stuff. Here again, we have hardly big tasks at the end, and this is what we want to tackle. Okay, let's do that. Let's jump into the code. And I already told you about this RxLet and 4 things. So I want to start by jumping into my movie list page. And this is what we see a lot. Many async pipes used all over the template. And I'm not sure if you knew that, but static as well as async observable values that have an async pipe are always not really good with initializing them. So you are forced to use this question mark clutter in the template, and not really nice, because with an observable, we should know when the data is here and when not. So for that, I suggest you to use the RxLet directive. The RxLet directive basically enables us to provide a observable, and then I can write the values of this observable to a local variable, and I can directly reuse that without using multiple times the async pipe. And guess what? As we did our job right with typing, we can also now reduce that question mark without getting any error. Really nice, cleaner template and performance improvements. Architectural changes. We have another async pipe here. We decided to pass observables directly. I just remove the async pipe, and here an ngIf. In this case, I would suggest to use the RxIf here to do that. Let me quickly switch to it. And that's it for the first layer. And then we can also jump into our movie list. Upsala. There is a space too much. Now it works. And in my movie list, we have this RX4, this ng4 that I can also refactor to another structural directive, RX4. And here I can just remove the async pipe, and it will work as is. Those were changes that only applies to this list page. So we get rid of the async pipes everywhere. We passed observables directly, removed all the question marks, and we also used the RxIf. Inside here, we use the RX4, and this is a tiny refactoring. Let's see the impact for that tiny refactoring already. I will jump here. It was that page that we refactored. Let me open it up and refresh it again. I hope that it is reloaded already. Yeah, this looks definitely different. Let me stop the recording. Let's wait. And
I created a graphic for you to say "Stand by." Michael is profiling on the screen.
Really nice. Really nice. Yeah. While we are waiting for that, and we are done. Now we can zoom into the last part of the flame charts, and we see nearly all blocking tasks are gone here already. Only this one, and at the most of it is style, and I can show you how to fix that later. So it's not JavaScript, it is only the DOM. But here, we have another one. What is this? Change detection. We go down, we see it is in our app shell, so most probably another ngIf that I can chunk up, and let's do that again. Let's jump to our app shell and use another time a little bit of the async pipe there. I go to the very top, and what I see here is, instead of using the async pipe multiple times in the template, we use the ngIf hack. We use the ng-if here not because we want to, in if-else condition, we just use it because we have the async pipe here in place for this observable, and we want to apply changes to this local variable that is called vs, view state. So instead of using the ng-if hack here, which is of course slow because of the async pipe, we can again refactor it to rxlet. It will work out of the box. Let vs. So now everything else is already working. And what I can do in addition, I go down to this rx4 here and also refactor it to an ng4 and refactor it to an rx4. Okay, pretty good. Do I have other things to do here? I guess no. Let's jump back to our slides. Let's wait until the page is refreshing. Let me quickly check if the build is done. Yes, perfect. So with this refresh here, I will do another measure. And now we should also reduce the time of rendering of the sidebar a little bit. I now stopped the recording earlier because I already know, otherwise Don would introduce you to this loading spinner graphic that he created. And if you look here, look at this. The chunks here are also gone. So I have not a single blocking task. I have one. What is this? Script evaluation. I'm not in incognito mode. Let's quickly fix that, or let's fix it later. And let's agree that even if you're not in incognito mode, the flames are beautiful. This thing here, I will show you later that it is gone. And we can see that there is still some room for improvement in the app shell. We could use some more rxlets to chunk that up. But for now, let's keep it. Let's keep it and let's make a quick recap on how many changes we did. And it is not a lot. It was a few lines here, 3 characters here, a few lines here, 1, 2, and a few lines here. This is quite a small change for this dramatic improvement, and we can go even further. Imagine that now what we did is we chunked up work in pieces automatically. Every piece that is wrapped in an ng rx4 in a rxlet or rxif is now in a queue, in a working queue that will perform work until I go close to a blocking frame. And here I have 30 milliseconds, and then I stop the work and reschedule it again into the next frame. And this is the trick why I can get rid of all the blocking frames. But what I can do in addition is focus on our largest contentful paint even more. And if we look at this, rendering of the page starts, we start, and you look at the site nav now, it starts to render the site nav, and after the site nav is rendered, now we start to bootstrap the left side, the component, and we start to display the content here. So we don't need to wait for the sidebar, but the problem is through our DOM structure and the whole structure of the application, we are forced to do that because the tree is as the tree is. Not in our case, because everything is scheduled and then things are different. So what I can do is I can jump into the app shell and I search for the list. I search for the list and I apply. Where is the list? Here, the list of side menus. And I apply another thing that is called strategy. Strategy. And here I pass the value low. You can read up about that stuff in detail in the online docs in the repository of RX Angular. For now, this is all I tell you. It has now lower priority than anything else in the page because everything else is the default priority. So I down prioritized rendering of the list. Let me also try to down prioritize rendering of the toolbar at the top. And I will try to find the toolbar, menu footer, sidebar, toolbar. Here we go. And I can make a trick here. I can say whatever is in the huge block here will get chunked up Rx let. And here I apply an empty array. For now, this is a hack. We will ship a structural directive later in the future. But what it does is it basically takes this array, which is an observable value, and immediately renders the page after it is scheduled. And as we can use scheduling techniques, I can also apply strategy low here. So now I used two different pieces in the app and prioritized them. Let's see what we get out with these 2 lines of code. And believe me, if this is not mind-blowing for you, I did a bad job in explaining it. We saw from before that we have to render the toolbar at the top and the sidebar, basically everything here and here first, before we could go to our largest contentful paint. With another refresh and measure now, I will stop even earlier. We used some more let's directives and so on. So we even chunked up these huge tasks here in 2. But what we did, if we look on these frames here, we basically now look at the side menu. We don't touch the side menu and don't do anything more at the top, and we start rendering the list in the middle first. And after it is done at the very end, you see now the side menu kicks in. And this is a game changer. With one line, we just prioritized a completely different part in your app, independent of the DOM, to have a higher priority. And this increased our largest contentful paint dramatically. Here, LCP is right next to the load. If we go to our previous measurement, you see that difference. Like, this is 400 milliseconds. Tell me that this is not an incredibly cool improvements with a one line in your app. Okay, we did a lot, and as you realized, we removed all the async pipes. We removed all the async pipes from our templates from everywhere, and this is cool because now we did an amazing job in refactoring for zoneless. Let me quickly check out so that we really are sure I did no mistake and I can save your time because we are at the very end of the talk. Let me first check out all improvements here and show you how to go zoneless, fully zoneless. Imagine you managed to get rid of the async pipes, and this is, as I showed you, pretty easy. Then you can jump into your polyfills and you can try to comment out zone here, and then you can do other stuff and you will see impacts. And let me first show you how bad it is with zone, the before and then the after. Okay, so we zoom into the Bootstrap phase in these flames, and I did a small thing and enabled the time panel, and here we see how long zone takes to bootstrap, not to load, to bootstrap. It's nearly 150 milliseconds, and there is also some time that we need to compile that stuff. So we could get rid of all of this, and in addition, a lot more work. As you can see, zone task, zone task, zone task. So zone, the blue thing, everywhere. Everything that is blue here is zone. And I will show you how easy it is with Angular to get rid of it. We go here, we exclude the import from zone.js, and we jump into our main and say, instead of using the real zone instance, we want to use a mock, a no operation mock. And we try to run our application again, and we see, and now I can do it in the incognito mode. Let me go to popular. Let me refresh the page again. Wait a little bit because it is rebuilding. And unfortunately, the one has no rebuilding spinner. So I hope that you can make that up in the meantime quickly, a rebuilding spinner. If not, it is rebuilt already, and you see a white screen. A white screen because there is no route, because routing is heavily tied to our to zone. So we have to fix routing everywhere. And how did I do that? I basically created, with another one-liner, a small service. This small service is used, for example, in my application component. And here I call it, I say zoneless routing init. So what happens in my init, I say if zone is not present, if you are running in a zoneless application and only if, otherwise don't do anything. So you could have it also running in zone full applications, it will not harm. Listen to the events. And if there is a navigation end event, call application ref tick. Or if you want to be even smarter, put the component here that owns the router outlet and call ChangeDetection ref detect changes. With that small change and another rebuild of my application, I can show you, luckily, that the application, if it reruns again, come on, runs again, is working again, and I can click and I can navigate around, and all the other parts of the application basically maintain those nice improvements. And let me do another remeasure now with the knowledge that we should see some improvements here and there. So I will click, I will of course open it up again. I will click reload. Tuck. I can stop again. If you realized, like, reloading is now taking seconds less compared to how much I had to wait for the beginning. And here we see, okay, a big task at the beginning, but no time taken from zone. And everything else is free of the blue stuff. So there is not a single thing left. And if I would not video stream, those tasks here would also be non-blocking. If there is stuff left, like here in the app shell, we can just use the RxLet with an empty array trick to chunk up pieces again and again. But I would call it a day for now. I showed you what zone basically does, and that you could get a huge impact if you get rid of zone. I showed you how to measure it and where the timing marks are, that you need to comment that out, use the loop, and call application ref tick. And then that's it. You can go from a very slow application to a nearly 100 out of 100. In this case, only one dot is left. And that's only possible because we worked really hard the last years on Rx Angular, a performance-focused and developer experience-focused application. So even if you're not into performance, your code will be cleaner, better typed, nicer to use, on top for free, all the performance stuff and the crazy prioritization. If you like it, star it or sponsor us on GitHub. My name is Michael again. I want to say thanks for all your time. If you're interested, feel free to contact me online. My company obviously is also running performance audits, and other refactorings are possible with our team in your application. Feel free to contact me, and I say thanks for your time, and I give the screen back to Dohan.
All right, thank you, Michael. That was an awesome talk. Great work. Yeah, I've used Rx Angular. It's a fantastic library. So please keep up the good work. And while you were talking, I did find a way where I can run this Raffle live. So I want to do that real quick. It's going to be exciting. And let me move some screens around. And all right, so let's see this. And then, all right, so share the screen. Okay, so I have my random.org screen here. And so if you would like to participate in the raffle, please comment now on the chat saying you would like a license. And this is the last call. I'll add your name to the list. I can see some more chats coming in here, but my UI is blocking me. I'm going to cheat here a little bit. Okay, there you go. All right. So I see some people commenting, but you didn't say you want a license. So please say I want a license.
There is one question. If I provide some discount for consultancy for Ukrainian developers, I mean, why not? You can just ping me and we hang out in a chat as long as you want. Do it. Definitely. Mr. Wotznik. Ping me on Twitter. Let's do it.
All right. So our last call for thank you, Marian, for your comment.
Thanks, Marian.
And also PS to John also had an amazing comment. Thank you for that as well. Okay, so anyone else? So currently you can see my list of folks I have on the raffle. I will give this, let's give it an official 30-second countdown. So
do it.
And I can create, by the way.
Give it an official 10 seconds because I need to go somewhere special.
Okay, all right. 10,
sorry.
9, 8, 7, 6, 5, 4, 3, 2, 1. All right. Well, I'm sorry if your name is not on the list. I'm hitting randomize, and then the top person is going to get the Wallaby JS, and then the second person is going to get the Koka JS. Let's go. All right, Aditya Menon, you get the Wallaby license. So please DM me on Twitter, and then PS to John, you get the Koka license. So thank you so much, everyone. And thank you, Michael, for taking the time to be
welcome.
Here.
It was really a pleasure.
And yeah. All right, everyone, have a great day. Thank you so much.
Bye-bye.
Bye.